So I want to welcome everyone to week 8 of xEssentials tonight. An essential topic, show networks for dummies. So I'm ready to learn. Kevin, you got the floor.
Cool. Well, good evening, everybody. My name's Kevin Rhodus, and like Ed said, I'm going to be presenting on show networks for dummies. So just a little about who I am. I am an application engineer for a commercial AV manufacturer. And so a lot of what I deal with all day long is network-based audio, video, and control systems. So we do systems all throughout stadiums, theme parks, airports, lots of very, very mission-critical applications. And the one common basis with all these is they require extremely complex networks that have sub-microsecond timing. So networking is extremely critical for what we do, and consequently, I deal with it a lot. So I also am one of the co-creators and founders of the Lucy Depp Park Light Show here in Columbus, Ohio. So it is a 7.5 acre drive-through show with 6 houses and roughly 150,000 or so channels. And we have a network that spans throughout the neighborhood, jumping a couple streets and everything, going between all the houses. So we have a fairly extensive network. We're not going to get that deep tonight on this, but if you are interested in how we do it, I've got our website right there, ldplights.com. We've got a pretty basic write-up, but some pictures of how we do it. And if there's some interest, I'll come back and do another presentation about how we link our whole neighborhood together. So diving in. So what is a network? So boiling it down to basics, a network is just 2 devices or more connected together to share data. So the phone system, the public switch phone system is a network. Your home Wi-Fi is a network. The internet is a series of multiple networks all tied together. So let's break it down with some of the hardware first that makes up a network. And part of the confusion that can be caused is, I'm sure everybody's familiar with this box right here. This box, is doing a lot of stuff all in one. And so, if I took a survey, even just asking everybody on the call right now what they would call this, I get, all sorts of answers. So we're going to break it down a little more into all the different functions and features that does. So our first device, the most basic part of building a network is your Ethernet switch. So the Ethernet switch connects multiple wired devices together, and we use it to send data between the devices on the network. The most basic networks really are just a couple devices plugged together in a switch, and that's how you can build a basic show network. One big feature with switches that is not in Wi-Fi, and we'll talk about Wi-Fi in a minute, is switches, when I send data from one device to another, it's only sent out the ports that need it. So I'm not sending that data out to everything. So you get some advantages with that. As you get into a little bit more advanced switches, they can also power the devices. It's something called power over Ethernet. So when you go to buy a switch, you'll see them rated by speed. You'll either see 100 megabit switches, which are sometimes called fast Ethernet. Those are becoming less popular as gigabit Ethernet switches are, becoming cheaper, and really there's no reason not to just buy a gigabit. It's hard to find just a fast Ethernet switch these days. Our next box, or next function, our good links this guy at the beginning does, is a router. So a router is really the brains of our network. Both consumer and professional routers usually perform a couple of different functions on the network. The first main function they use is they connect different networks together. So at home, your router connects your local network out to the internet. In a business, it might be used, their network might be segmented into multiple smaller networks, and the router ties them all together. The other main function that a router handles is something called a DHCP server, and we'll talk about that more later, but that's how devices get their addresses. So almost every single network especially any network that touches the internet will at least have a router in it. And then the last piece of hardware that box does is it acts as our Wi-Fi access point, or commonly called WAP or even AP. So all an access point does is convert hardwired network into wireless. Most consumer access points that you see have routers built into them, but you can get versions without, like this Ubiquity up here on the screen. This is solely just an access point. It doesn't do any routing functionality or anything. It just converts wired to wireless. Probably everybody's familiar with hearing 802.11a or B or G or N or AC or whatever they're up to today. Those are all the speeds at which the router can operate, so the maximum speed. One thing to keep in mind, though, when you are using Wi-Fi, is there's only so much bandwidth that an access point can support. So it can only put out a certain width of radio frequency. If I have one device, you know, it can use a lot more than if I have 100 devices, because all 100 devices have to fit in that same amount of bandwidth. So the more devices per access point, the slower overall speeds. And, you know, that pack is being broadcast out everywhere that's going between them. And the last part I wanted to touch on just a little is cabling. Everybody's probably familiar with Cat5, Cat6. So what that stands for is CAT is for category twisted pair cabling. And as you can see in the pictures, it's really a series of 4 pairs of cable that are twisted together. And the higher the number you go, the tighter the twists are and the faster speed it can carry. For lighting and everything we're doing, Cat5 or Cat6 is plenty sufficient for what we're doing. When you go out, you know, to the store, you're looking online and buying them, you'll see all sorts of different things. You'll see shielded, unshielded, plenum, riser, direct burial, UV, all that good stuff. Most of that doesn't matter. Plenum is a rating for commercial buildings, and it doesn't really apply to us. You know, you don't need to buy plenum cable. Shielded cable, there's really no advantage we get from shielded cable. It's used in like video over IP scenarios where you have multiple cables together and you don't want them to interfere with each other. When you're running cables on the ground outside, it really doesn't matter. If it's a permanent install you're doing, like up to the access point I have up on my roof, I would recommend using outdoor rated or direct burial cable. But if it's just temporary, like the thousands upon thousands of feet we use a year, standard cheap Cat5e riser cable that you can get from Lowe's is plenty sufficient. The cable connector on the end is called an RJ45, and you can either buy your cables pre-made or terminate your own. It's really easy to learn how to terminate cables. I highly recommend it. You'll save a bunch of money. The one thing to watch out with cabling, because I've seen this bite people a lot, is copper-clad aluminum. So they're sometimes called CCA. It's a way cable manufacturers cheap out on building cable. And basically, instead of being pure copper inside there, they take aluminum and they dip it in copper to make it conductive. The problem is aluminum breaks a lot easier than copper does. So the cables are much more brittle. So whatever savings you get up front, you'll usually pay for it by having the cable break and everything. So I would definitely avoid copper-clad cable. So we've seen sort of the different devices and everything. How do they actually talk in a network? So here's my house. I'm at 123 Main Street. You know, pretty simple. That's my address. In my computer world, I have the same thing. It's called an IP address. So my laptop right here has an IP address of 192.168.1.123. So an IP address is made up of 4 numbers, and they all range between 1 and 125, and they're called octets. Sometimes you'll hear people refer to them as that. So looking at our IPs, there's a couple rules that go along with our IPs. The first is what numbers we can use on our home network or our show network. So all IP addresses are really broken up into two different ranges, the public internet range and private IP range. So public internet range is, how your computer talks to Google and Facebook and the xEssentials website and everything. The private IP range is a set of numbers, and you can see it up there on the screen. There's a range in 10 dot, there's a 172 dot, and a 192.168 dot. All those IPs, your router knows this is a local IP and doesn't send it out to the internet. So if you're making your own network, and we'll talk about some scenarios where you set up your own IPs, you need to make sure it's in one of these three ranges of IPs. The second main rule, pretty simple and straightforward. You can't have two devices with the same IP address on the same network. Now, like my house before on there, it was 123 Main Street. There can be a 123 Second Street. So if I have a 192.168.1.5 on my network, you might have the same IP on your home network. Because both our routers know that those are private IPs, that's okay. What I can't do is I can't have two 1.5 devices on my home network because the network would get confused who is who. And then the last rule, on most home networks, you cannot use .1 and .255. Those are special and reserved. Usually .1 is your router, and then .255 gets into some advanced topics we aren't going to get into today. But so just know if you're coming up with IPs, use between .2 and .254. So how do we get our IP addresses? So most networks, especially if you have a router, you'll plug in, and there's a protocol that happens called DHCP, and your computer will say, hey, I need an IP address, and your router will come back and say, hey, here's your IP address. So if my laptop before was on there, the router said, hey, you're on .123. Typically on the network, there's a range of IPs that router gives out. For some routers, it's like .100 to .200. It all depends on your router. That's called the scope. So your router will hand those IPs out. Most people don't have over 100 devices connected to their home network, but occasionally, you have people like me that do. What happens when you run out? So part of that DHCP is after a certain amount of time, it's like between a day and a couple days, your device will either ask for its IP address again, or the router will check to make sure you're still there. If your computer's not there, the router then will give that IP out to somebody else who asked for an IP. So the problem we run into with that in lighting is we need to know the IP address of our controllers. If my controller grabs .123, but then I unplug it for a day or so, or it just happens to line up that it loses it, and now my Apple TV grabs 123, I'm going to have xLights or Falcon Pi or whatever I'm sending my show data from trying to send to that IP. So that can cause a lot of issues. So there's two ways we solve that. The first is called DHCP reservations. And I'm not going to teach you how your router works, but it's something you can easily look up. And it basically says, always give this device that IP address. The second is by doing something called setting the IP static. And when we set our IP static, all we're doing is simply saying, hey, always communicate on this IP address. And so our device will always be on that IP address. Now, one thing we got to watch out, if we do that, we want to make sure the static IP we're setting our device to is not in that pool of IPs that we give out with DHCP, because the router doesn't know our device is there. Our device never asked the router for an IP. And so if I accidentally set it in that range, I might have my router accidentally give out that IP address. So make sure when you're setting it that it's outside of that DHCP range. The other thing to know with that too is I might set up my F16 to be an IP of 192.168.1.5, but I get a new router at home and it's using 192.168.5 IPs. My F16 won't know, hey, I need to be on a 5.IP. It will always be on that IP regardless of what IP the rest of the network is on. So just something to keep in mind with that, knowing what range you're on, especially if you're trying to talk to it from your home network. So taking this to the next step, if I want to send a letter to my neighbor at 124, that's really simple. I don't need to know I don't even need to know my street name. I don't need to know the city, the state, the zip code, any of that. I can walk next door and put it in his mailbox because he's right there on my street. So how do we figure out what's on our street in our IP network? So if I want to send a message from the laptop on the left at 123 to the laptop on the right at 124, how do I know that's going to get there? So the second part when we're of our IP address is what's called the subnet. This can get into a very, very deep topic, but we're gonna approach it from a very bird's eye view right now, because most home networks follow this. So you see that subnet is 255.255.255.0. What that means is every time we see a 255, we ignore it. And what we're saying is we're going to ignore, we ignore that octet or that group of IPs. So anytime we see a 0, it means we can talk to that. So for example, the first 3 are crossed out. The last one I can talk to. So I can talk from .1 all the way to .255. This 255.255.255 subnet, probably 90+%, if not higher, of home routers use this subnet. And it's used immensely in commercial net. Most networks are set up with this way. So you can talk from .1 to .255. We can do a whole nother presentation on subnetting, but it's not as scary as it seems. And then the last part of our IP, say I want to send a letter to Google. Well, Google doesn't live on my street, so how do I get my letter there? I have to send it to the post office. I send it to the post office. Post office knows how to send it out to Google, and then they send it there. So if we look at that on our computer, I've got my IP. Based off what we just saw with our subnet, I can't talk to that IP. So how do I get that message to Google? And that's where we use our router. So I send my message to our router. Remember earlier I said the router has 2 IPs. It has one on our local network and one on the internet. And if we look there, our router just magically happened to be in the same range as Google and now can send that message to Google. So how do we tell our computer to send it to our router? And that's our gateway. So the IP, when you set an IP, it's made up of 3 different parts: your IP, your subnet, and your gateway. The gateway is the IP address of the router. And what it does is your device, when it has a message to send out, it looks at it and goes, okay, this is on my subnet, I can send it. Otherwise, if it looks at it and goes, I don't know where this IP is because it's outside of my street or my subnet, it sends it to that gateway. And then once you have that gateway, then we can go out to the world. So the first rule of gateways is we don't need gateways. If I'm just talking between a Pi and a Falcon controller, and that's all I'm doing, I don't need a gateway address because they're staying on the same network. All those messages are staying between there. However, if I want my Pi to be able to talk out to the FPP update server, that needs to go out to the internet. It would need a gateway. One common thing I see a lot, and we'll talk about it at the end again, if that Pi, a Pi has multiple network interfaces, has a Wi-Fi interface, has an Ethernet interface, you should only ever have one gateway set. If you set multiple gateways, it's like writing multiple zip codes on a letter and putting it in the mailbox. The post office isn't going to know which other post office to send that letter to. So it might send it to the first one sometimes, and it might send it to the second one sometimes. You only ever want one gateway. So if I have something like my Pi that's on multiple networks, I only want to make sure I have one gateway. And then, like I said just a minute ago, if we wanted to reach out past our network, we need to have a gateway as well. So applying this all to our shows. So why do we build a show network? If I ask 10 people on this call, I'll probably get 10 different answers. My personal and professional opinion from dealing with critical networks like this, I am a big fan of always having an independent network. And there's a couple reasons. First off, it's a lot easier to manage, troubleshoot, and configure. If I take down my home network at home, my wife will kill me. If I have a show network and I take it down, I can take it up, down, left, right all day long, and nobody will know. The other big thing is we want to keep our data separate. So if I'm running everything on my home Wi-Fi, I'm sharing that data with Netflix, with Facebook, with iPhone, iOS updates that might happen in the middle of a show. All that stuff is a lot of traffic that we're also trying to compete with our show data. And so what happens is you'll have a packet get delayed or lost. If I'm just trying to load a web page, that's not a problem. The web page will send me that packet again. But when I'm doing something like streaming lighting data, that becomes a big issue because now I'm missing parts of my effects. There's also a phenomenon in networking called jitter, where jitter is when I have high loads, or even just, it doesn't have to be a crazy high load, but I have a lot of activity on my network, packets or bits of data arrive at different times. That can really cause lighting effects to really look wrong if I've got packets arriving at different times and it's inconsistent. And then the final reason is survivability. So our show's out in the middle of the woods. I lose my internet connection all the time. The first thing my cable modem does when it loses its connection to the Time Warner is it automatically reboots. Well, if I'm running my show off that, now my whole show network just rebooted and went offline. And a lot of routers, when they reboot, don't remember their DHCP addresses they gave out before. Everybody gets a new IP address. So now everything is getting a new IP. If I forgot like I did before and I just was running off the DHCP addresses and stuff, devices might start getting different IP. So it's much, much better, in my opinion, to have this all isolated. And then there's a couple of ways I'm going to show that we can connect to that network. So what does that look like? Our most basic network is simply just using a switch. So I've got my F16, I've got my Pi, and then I plug in my laptop. And there's my show network. Pretty simple. So looking at this network, all our devices on this network have to have our IP addresses set static. It doesn't matter what range I use on this network because it's just by itself. However, one problem with this design is I don't have DHCP. So if I plug a new device in the network, it's not going to get an IP address immediately. It's going to take a couple more steps to get that onto my show network. This is the simplest, most foolproof network design. We use it all the time in the AV world. We call it systems on an island. It stands alone by itself. There's very little chance of anything going wrong on the network. It's pretty rock solid and simple. One thing to know, though, is we have no internet access on this network. So if I need to update FPP or update my Falcon, I either have to connect those back to my home network or manually do it. There is no internet. And our laptop that was plugged in, unless it's also connected Wi-Fi to my home network, it's not going to have internet. So the next step upon this is let's build in a router to this. So I still have the same wired network, but I'm going to put a router, a separate router, not my home router, but an independent router in place for my show network. The advantage this gives us is now I have DHCP for devices that plug in. So when I connect my laptop, I don't have to set my IP static every time I do it. I just connect either Wi-Fi if my router has Wi-Fi, or I plug in to a port on the router or a port on the switch. You can connect switch upon switch to routers. It adds a lot of nice convenience to that. So when we're doing this, we still should set our show devices either static or a reservation so that they're still on the same IP. And like I said earlier, we want to make sure they're not in that DHCP server range that it gives out. If our router has Wi-Fi, we want to make sure it's on a different Wi-Fi channel than our home Wi-Fi. That helps prevent a lot of interference and everything between it. One cool thing we can do with this is our router for our show can be connected either wirelessly, if some support it, or hardwired to our home network to get internet access for those devices on the show. If we do that, though, we need to make sure the range of IPs we're using on our show router is different than what our home network is. So if our home network are 192.168.1 IPs, we want to make sure our show router is giving out 192.168.2 or 3 IPs. We don't want those ranges to be the same. And in this network, I see a lot of people do this, and this is another great design, is you run a show network just like we did before, either with or without a router, but then we connect our Pi back to the home network over Wi-Fi. And so that way I can connect from my home network devices to my Pi, but all my lighting data is staying on a different network. So with this, you have to make sure your show network and your home network have different IP ranges. Otherwise, the Pi won't know which network to send that data to, and it might start trying to send lighting data out to your home network as opposed to your show network. The other thing with this, you're not able to directly access the devices that are on the show network unless you connect to it with your laptop. So in that scenario, I can't connect to the F16. I can connect to the Pi. Now, xLite has some really nice abilities to do FPP proxies and connect through, so that's not as big of an issue anymore. But if you do actually need to get into that device, it's just something to keep in mind. In this scenario, when we set it up, typically we're going to want the Pi to get DHCP from our home network, and then we'll set a static IP for the wired network. When we do that, the wired network does not need a gateway. I've seen countless times where the wrong gateway is put in or the gateway is put in on the show side. You don't need that because we're not talking beyond that show network. So, we want to put the gateway on the home network side. And you can either do DHCP on the home network, or you could set that static on your home network so you always know what IP it's got as well. And the last design, this is what we run for our show. So if you want to go really, really over the top, you can, we can talk later about how to build a network like this. So.
Thank you. Very complex topic. You started simple and it got pretty advanced and very enjoyable. So I do appreciate it.